Yeah, good evening, ladies and gentlemen. We are very sorry that it will take another 2-3 minutes because our president is connecting. Uh, there is a power cut, as you know, that there are some issues these days, right? So please bear with us for another 2-3 minutes. Engineer Sahabandu, shall we start?
Yeah, we can start it now.
Yeah. Thank you very much. Good evening, everybody. This is our second Geo Forum of this year, 2022. To officially welcome the presenter to this presentation, I would like to invite Engineer KLS Sahabandu to make a brief introduction about the author, or about the presenter. Thank you.
Good evening, everyone. Welcome to Geo Forum of 2022 February. This is a monthly event Geotechnical Society has launched so many years back, and every month we try to get this lecture organized for the benefit of our members as well as the public. And also we normally invite eminent personnel who is contributed in this field to share their knowledge with our members as well as public. Today our resource person is Dr. L.I. Nalin De Silva, who is a senior lecturer at the Department of Civil Engineering of the University of Moratuwa since 2009. He got his bachelor degree from the University of Moratuwa with first class honors in 2001 and obtained his master's and PhD from University of Tokyo in 2004 and 2008 respectively. He is a corporate member of the Institution of Engineers Sri Lanka and a member of the Sri Lankan Geotechnical Society and the International Society of Soil Mechanics and Geotechnical Engineering. He served as the editor newsletter in Sri Lanka Geotechnical Society in many years. He has over 12 years experience as a geotechnical engineer, and he has been providing his services as geotechnical consultant for major construction projects in Sri Lanka and overseas. He has published many technical papers in the conference in Sri Lanka and overseas, and also worked as a resource person in many workshops, training programs, and seminars. He is a holder of the national patent right of force sensor with cross-beam structure for earth pressure measurement. His national patent is LK-P270. With that brief introduction, I would like to invite Dr. Nalin De Silva to make his presentation. Podium is.
Thank you, Engineer Sahabandu, for your very this informative introduction about myself. So, since I am experiencing a power cut, let me close my video and do the presentation to save some battery life of my computer. Hello, can you all see my?
Yes, Dr. Nalin, we can see you. We can see the presentations. Yes.
Right. So, good evening to all of you, and welcome to the SLGS Geo Forum. This is the two-day lecture series, and the first day of the lecture will be focused on the construction and analysis and design aspects related to deep excavation. So this will be, basically I'm focusing on the construction issues, how to select an appropriate type of deep excavation support system, what are the methods available for analysis and design, and in the second day I am planning to discuss about dewatering aspects, and most importantly monitoring and contingency plans in case of unexpected events. Then some quality assurance and safety aspects will also be discussed in the second day. So with that, let me start my presentation. So this is the content. So today I am going to talk about the different types of excavation support systems and the criteria for selecting different types of support systems, what are the methods available for analysis and design, and I will be presenting some tools that will be really useful in planning stage. I'm not going to go into the details of analysis and design, that is not the scope of this presentation. So but I will be explaining some useful tools that can be incorporated with monitoring records in the planning and construction stage to ensure the safety of deep excavation. So these two sections will be covered today, and the remaining three sections will be covered in the next day. So let me start with an introduction. So deep excavations are generally classified as the excavations deeper than 6 meters. So excavations less than 6 meter, we can either support them using open cut excavations, and that means excavation without any lateral support. So the excavation has to be cut at a safe angle to prevent the failure modes given here. The different modes of failure for open cut types excavations are presented here, so I am not going to go into the details. So let me start with open cut type excavations. Some general guidelines are presented here. I took these guidelines from Occupational Safety and Health Division of North Carolina Department of Labor, USA. Some nice guidelines are available on open cut type excavations. The soil types are classified into three categories as type A, B, C, as shown in the left hand side. So different soil classes or types are classified. The type A is mainly stiff clay type soils. Type C is mainly sandy or gravel type soils without any cohesion, and type B falls into the soils that are in between. For these three types of categories, and you can see the approximate SPT values are also given for the types of soils. For the different categories, the acceptable slopes are given here, and these guidelines can be used if there are no structures on the top of the excavation. If the excavation is not done in a residential area, so these general guidelines can be effectively used. So if there are different layers, the same guideline provides general specifications. When you have say a type B soil over type A over type B, and so on. So different the layers, layered soils, the specified slope angles for open cut excavations are presented in the guidelines. So then I would like to move into the different excavation support systems. So there are several types of embedded walls used to support deep excavation. The criteria for selection mainly depend on the area of excavation, the ground condition, groundwater table, and the allowable deformation of the wall, and the anticipated settlement of the retained side of the excavation. Then one major consideration is the availability of the construction equipment and cost. Then one more important aspect is the water tightness. So by considering this, we can select different types of the embedded type retaining walls. So some options for the selection of the different types of embedded type retaining walls are presented here. I will be briefly going through these the different types of embedded retaining walls for your information, just for completeness, and some will be explained in detail because some techniques are quite new and novel to Sri Lanka. So let me start with the applicability of these different types of the excavation support systems for different conditions. This table presents the available different types of deep excavation support systems and their applicability for different excavation heights. So generally the excavation support system can be maintained as a cantilever excavation if the excavation height is, say for example, less than about 5 meters. So excavations greater than about 5 meters need to be supported, propped or anchored, and depending on the groundwater conditions we have to select the appropriate the type. So this table can be used as a guideline for the selection of the appropriate the type of excavation support system. Let me start with the solder pile walls. The solder pile walls are very widely used and in the solder pile systems, steel eye sections or sometimes the railway, what you call the steel eye sections and the other types of like precast type of leggings are also used for solder pile retaining walls. And in some cases if the excavation depth is large, these walls are anchored, and different lagging options are given here. In some cases the eye sections are embedded in soil and in some cases the eye sections are exposed. So different lagging options are also there. Then comes the sheet piles, and sheet piles sometimes we have to in case of hard driving conditions we may have to use jetting or pre-drilling to assist the installation. The corner connections are also given here, so I am not going to go into the details of this. Then comes the contiguous pile walls and secant pile walls. Let me spend some time here because in the contiguous board pile walls where groundwater control is has to be considered, the grout piles are constructed behind the contiguous board pile walls to arrest any seepage through the wall. And secant pile walls, as you know, they are kind of interlocked. The primary piles are first installed and then the secondary piles, which are reinforced, generally reinforced, are installed. And depending on the selection of primary and secondary piles, have hard to hard type secant piles and hard to soft type secant piles. In hard to soft type secant piles, this kind of secant pile walls are suitable in relatively stiff soils because this the primary pile consists of cement, sand, bentonite mix, so it's not very stiff. So that is why it is called hard to soft secant pile technique. One of the major problem in secant pile walls is the loss of overcut at great depths. So most of the secant pile failures are due to this because generally for secant piles an inclination, a tolerance of about 1 to 75 is allowed. So there can be a situation where at great large depths the overcut is lost, and the gaps are exposed. So if the subsurface condition is sandy and the groundwater table is high, the seepage can take place through the wall. So that has to be considered in selecting the secant pile walls. So most of the secant pile wall failures I have seen are due to this problem. So generally speaking, if the water table is high and the depth of excavation is more than, let's say, 7 or 8 meters, and the subsurface consists of sandy soil, better to avoid secant piles. That is my advice. So different secant pile configurations, typical details are given here. So I'm not going to go into the details. I will share this presentation with you so you can keep it as a reference in case. So the first two are like heart to heart type secant pile typical details. First, in the first one only the secondary piles are reinforced. In the second case, both primary and secondary piles are reinforced. The primary piles are encased, steel encased. So the last two are hard to soft type secant piles, secant pile walls. Then comes to the diaphragm walls. So in the diaphragm wall, the construction technique is quite simple, and this is now widely used to support deep excavations in Sri Lanka. So you have to have a guide wall. Guide wall, it is sometimes masonry guide walls are used. In some cases, precast concrete guide walls are also used. Then you have to excavate a panel, and the panel has to be supported. The excavation has to be supported using a slurry, using the drilling mud. Bentonite is used. Then two stop pens are used. With these two stop pens are generally equipped with some water bars to arrest seepage through the joints, and then this panel is concreted. And the same procedure is repeated for the different panels. These the stop pens can be either steel tubes, precast elements, and so on. Different configurations are there. So I would like to show you some available the water stoppers. The consistency of the drilling fluid is given here. That's quite similar to the consistency of bentonite during piling. And according to ICE specifications, it is recommended to use a single tremie for panels less than 3.6 meter in length. Two tremies are recommended for panels between 3.6 to 7.2 meters in length. These are the connections, different connections available, typical details. In the first, the top left hand figure, you can see a steel stop pen is used. The excavation is carried out, cage is inserted, and then that part is concreted. After that, the stop pen is removed, and the same procedure is applied for the adjacent panel. And in the second case, the precast elements with you can see water bars are used as the stop pens. So in this case, the stop pen is not removed. This will become part of the diaphragm wall. It becomes permanent part of the diaphragm wall. Likewise, different the connection details are available. So so in Sri Lanka, this is very widely used. Can see a typical stop pen used in for most of the diaphragm walls in Sri Lanka. In this case, two water bars are used. but most of the cases in Sri Lanka we are using single water bar. So this part will be embedded in concrete, and once the panel is cast, the stop end is removed and you can see the exposed part of the water bar, and this part will be concreted next. So some more details on the stop ends are shown here. Then this is quite new to Sri Lanka. I have not seen prefabricated diaphragm walls in Sri Lanka, and prefabricated diaphragm walls are precast. It consists of precast segments, and the trench is filled with cement bentonite slurry. So this cement bentonite slurry will be hardened with time, and it creates a barrier for seepage. So no additional stop ends are required in this case, because this cement bentonite slurry itself will act as the water stopper. So the length of the prefabricated element actually depends on the structural capacity. Okay, in some cases 40-meter long sections have been reported in the other parts of the world, and anchor segments can be positioned very quite accurately during the installation time. So with the minimum disturbance we can install the prefabricated elements. And one of the biggest advantage of using prefabricated diaphragm walls is the ability to control the thickness, because these segments are cast in a yard under controlled conditions. So it is mentioned that the thickness or the width of a precast diaphragm wall is generally 30% smaller than the thickness of the cast in situ diaphragm walls, and the water tightness is also much better compared to cast in place diaphragm walls. And one of the biggest advantage of using precast diaphragm walls is the ability to post tension these elements. So post tension diaphragm walls are also being used. The cable profile has to be designed, so a lot of structural detailing has to be done, considering the level of supports and other lateral support, lateral earth pressure and so on. We have to design the tendon profile. So this will the use of post tension diaphragm walls will further reduce the thickness of the conventional cast in place diaphragm walls. Then comes top down constructions. Top down constructions are also used to support deep excavations. The top down constructions are quite suitable if the soil is relatively stiff and water table is quite low, or the permeability is quite small, like stiff clay type of soils. This kind of top down constructions are suitable. You have to excavate, carry out a free excavation, vertical free excavation up to about 1 to 1.5 meters. So soil must be stable up to that depth. Then we can install the precast elements, or you can support this by cast in place concrete, and these elements can be appropriately propped or anchored, and stage wise we can carry out the excavation. The soil nail walls are also getting popular nowadays. The one soil nail supported deep excavation is currently I'm involved in one in Kandy. The anchors are normal soil nails, and the facing can be either like normal soil nail facing, or sometimes micropiles are also used as the facing. The caissons are actually mainly used as a foundation. These caissons are very rarely used as an excavation support system, but there are cases where caissons have been used to support the deep excavation. This is again a top-down construction, and pneumatic caissons are used for carrying out excavation under water. So there is a pressure chamber. So people are working in the under the pressure chamber, and the pressure, air pressure inside the pressure chamber is larger than the water pressure. So that will prevent water from entering into the excavation. So people have to work under high pressure conditions. So there are a lot of safety concerns, and it is very labor intensive because people can't work for more than 1 or 2 hours inside these high pressure chambers. So they have to provide airlocks, and a lot of safety features are to be adhered, and it is quite labor intensive. Therefore these the caissons are not very widely used nowadays, but they were very popular in 1920-30s. And in some cases jet grouting and deep cement mixing is also used to support deep excavations, but jet grouting and deep cement mixing are mainly used as a ground improvement technique rather than excavation support system. But there are situations where jet grouting and deep mixing has been used in combination with other methods to support deep excavation. So in jet grouting, so first we have to drill about 100 to 100 millimeter diameter hole, and then high pressure jet is injected, and that will loosen the surrounding soil, and it mixed with the surrounding soil will be mixed with the grout, and about 0.5 to 2 meter diameter grout column is created using the jet grouting technique. And jet grouting technique is very widely used and can be very effectively used for seepage control applications in deep excavation. So it is rather than as an excavation support system, it is widely used in seepage control applications in deep excavation. And jet grouting is also widely used for underpinning applications as well. You can see some pictures. Jet grouting has been used in combination with piles to support a deep excavation. So few examples are shown here. Some typical details are given. I am not going to go into the details. So jet grouting systems are single fluid, double fluid and triple fluid types are now available, and the different systems have different advantages and disadvantages. So I am not going to go into the details of this. But jet grouting plants and equipment. Then comes the deep mixing. Deep mixing is also mainly used as a ground improvement technique than an excavation support system, but again it is used in combination. So two methods are available: wet mixing and dry mixing. In the deep deep mixing, in situ soil is mixed with some hardening agent, cement, mainly cement, and the large diameter columns are created. So in the wet mixing method, wet slurry is mixed with in situ soil. In the dry mixing method is suitable if the surrounding soil contains lot of moisture. So in that case, a dry binder is injected and it is mixed with water and soil to create deep mixing columns. So some details are given here. I will skip this to save time. So different configurations of deep mixing equipment. And deep mixing is very widely used for offshore ground improvement applications. Yeah. But if we are going for a deep mixing, lot of laboratory testing is required to select the appropriate mix proportions. So in situ soil has to be mixed with different mixed proportions of the binder, and the appropriate consistency has to be selected by doing a lot of laboratory tests. Okay, the top-down construction method. This method has been used for the construction of the new Odell shopping mall. In this case, the excavation is supported using a diaphragm wall or some kind of retaining structure, embedded type retaining structure, and then the ground floor slab is cast. Because this you can't excavate the entire area. This some area has to be used, right? It has to be continuously used during the excavation also. So the ground floor area is cast, and some opening is maintained for the carrying out the excavation. So after that, the excavation is continued up to the next level, and these are the piles, and the final excavation level is shown here with at the top of the pile cap, and these are the steel eye sections. So steel eye sections are taken all the way up to the ground floor slab level, and these eye sections will be encased in concrete. Okay. So the ground floor slab will be supported on the steel eye sections. Then you continue the excavation up to the next level, and the second level slab is cast. After that, the columns are concreted. The same procedure will be continued up to whatever the final excavation depth. So special structural detailings are required at the connections. So this method is widely used in highly populated areas where you need to continue to use the space at the top. You can see some pictures taken during a top-down construction. The one slab is cast, and they are preparing the columns to be concreted. And you can see the opening. This opening will continue all the way to the bottom. Then if the excavation area is quite large, so one can think of using the island method to carry out the deep excavation. So in the island method, so you have to have an embedded retaining wall to support the excavation, and the soil in the excavation is excavated at a slope, and this slope will provide some buttress support, passive resistance against the movement of the retaining wall. and you continue the excavation along a slope up to whatever the final excavation depth. Then the central part of the structure is constructed, middle part of the structure, and that middle part is used as a prop, is used to prop the remaining while continuing the remaining excavation. So this is called the island method. Right. Then I would like to discuss a little bit about the different lateral support systems available to prop and anchor the deep excavations. You can have the struts, raking struts, and horizontal struts, diagonal struts. So some typical connections details are given here, so I'm not going to explain them. And in some cases the struts are supported with hydraulic jacks. Then by changing the force in the hydraulic jacks, we can control the movement of the retaining wall, movement of the excavation support system, that is the wall. So in some case the hydraulic jacks are simply connected to this kind of welded sections. In some case the strut consists of telescopic elements like this, and the hydraulic jacks are used to control the movement. And these are the modern hydraulic strut supports. So they come in segments. So by connecting different segments, we can adjust the length of the support. And these large diameter hydraulic strut supports are capable of supporting deep excavations up to a span of about 40-50 meters. There are cases where hydraulic struts are used to support 50-meter spans without intermediate king posts. So there are no intermediate supports. The entire hydraulic strut takes the lateral load, and these hydraulic struts are capable of taking loads up to 5,000 kilonewtons, 5,000 kilonewton axial loads, and they are capable of controlling a wall movement of up to about 500 millimeters. I have seen this kind of the hydraulic strut being used in the construction of new Colony Bridge. Some deep excavation has been supported using some of the hydraulic struts. And you can see some actual pictures of hydraulic struts, and these are the hydraulic jacks. This is a telescopic segment. So by changing the hydraulic force, you can control the wall movements. So some pictures of some deep excavation supported using hydraulic struts without any intermediate king posts. Then comes anchors or tiebacks. You have deadman type anchors. Sometimes piles are used as anchors. Then soil lays, grouted anchors or helical anchors are also being used. You can see an installation of a helical anchor to support a deep excavation supported using sheet piles. One advantage of using helical anchors is the ability of the removing the helical anchor after the construction. This can be taken out, can be removed and reused. Right. So with that small introduction to different available different types of deep excavation support systems, I would like to discuss a little bit about some tools that can be used in the design. And there are different approaches available for analysis and design. Working stress approach is the factor of safety approach. And under the working stress approach also different the codes are using different methods in some old codes. The factor on depth of embedment is used. So the depth of embedment is calculated using the limit equilibrium method, and that depth of embedment is increased by about 20% to maintain the adequate safety. So that is still being used, widely used in the BS 8.2 factor, the last method, that is factor on shear strength parameters, both active and passive side. This has been used. Okay. And these are all limit equilibrium methods. In the new Eurocode, the limit state approach has been proposed. So in the limit state approach, partial factors are applied against the loads. It is known as actions in the Eurocode, and soil properties and resistance. So different partial factors are proposed considering different aspects. So the excavation support systems that are cantilever type support systems, or excavation support system with a single level of support can be analyzed using conventional analytical methods like free earth support method and fixed earth support method. Walls with single or multiple level supports can be analyzed using approximate analytical methods like PEC method, and nowadays finite element analysis is widely used. I would like to discuss about the finite element analysis a little bit towards the end of this presentation. Some advantages and disadvantages of the analytical methods are shown here. I am not going to discuss this to save time. And the different the failure modes that we have to consider in the design are shown here. Some are due to a soil failure, and some are due to the failure of the structural system, like failure of the wall, failure of the prop supports. And one important failure mode is the stability of the excavation against hydraulic failure or piping failure. So these are the different failure modes for an embedded type retaining wall supported using anchors. So in addition to normal failure modes, we have to worry about the stability of the anchor supports and the overall. And this is again important. The excavation supported using anchors, if the anchors are pre-stressed, there can be a bearing failure also. Okay, because large vertical loads are applied at the bottom of the retaining wall, bottom of the embedded type retaining wall, and since the width is quite small, there can be a bearing failure at the bottom. So so in addition to all these conventional types of failure modes, we have to worry about the bearing failure if the anchors are pre-stressed. So these are the failure modes for soil nail type soil nail supported embedded retaining wall. So I am not going to go into that. Approximate earth pressure distributions proposed by Peck are shown here for different types of soils: sand, then the soft to medium type clays and stiff clays. So these earth pressure diagrams can be used to approximately calculate the prop forces, and we can use these earth pressure diagrams to check the stability of the retaining wall against overturning failure. Then one very important the tool that can be used for ensuring the safety of the excavation is the basal heave. The factor of safety, a lot of analytical tools are available to evaluate the factor of safety against the basal heave. So this is for clay type soils. If the soil consists of clay, the factor of safety against the basal heave is given by this equation, and in this analysis it is assumed that there is the wall penetration, the penetration of the wall below the formation level, below the excavation level is neglected. So whatever the factor of safety calculated here can be considered as quite conservative. So it is generally recommended to maintain a factor of safety against the basal heave more than 1.5. So this is again for factor of safety against the basal heave for different H/B ratios. This height is smaller than, when the height is smaller than the width, you can modify the previous equation slightly, and when there is a very stiff or hard layer at a finite depth, then the equation modified as shown here. Similarly, for sandy soils also, factor of safety against the basal heave, the equation here. So someone is
எனக்கு சுவிட்ச் போடணும், மேல போட்டு இல்ல.
நீயே மேல போயிடுறியா? இல்ல நானே போறேன்.
Well, can you please switch off?
Wait,
இங்க வாங்க இருட்டுல இருந்து படிக்க.
Dr. Nalin, you can mute all those people.
yeah, okay, I'll do that. Now okay, right?
Yeah, now it is okay, I think.
Yeah. So this is this figure is very useful in assessing the stability of deep excavation during the construction stage. In the y-axis you can see the normalized lateral wall movement, that lateral wall movement divided by the excavation depth, and the x-axis is the factor of safety against the basal heave. So it is generally recommended to maintain a basal heave greater than 1.5. So when the excavation is ongoing, we can monitor this normalized the lateral wall movement and compare with the factor of safety against the basal heave. So this can be used as the control or tool in assessing the stability of the excavation. And these figures show the depth of embedment, the required penetration or the depth of embedment to cut off to the seepage to prevent hydraulic failure, right? So again, it is recommended to have a factor of safety greater than 1.5 against this hydraulic failure. So you can see in the x-axis width of the excavation divided by the head difference, the water table drawdown. So and let's say you want to maintain a factor of safety of 1.5, then by referring to the appropriate curves, you can see that these dash lines represent loose sand. If the soil consists of loose sand, and these solid lines are for dense sand, and we can estimate the required depth of penetration to maintain a factor of safety of 1.5 against hydraulic failure by referring to this diagram. And this diagram can be used if the depth to the bedrock or an impermeable layer is uncertain or unknown. If the depth to the impervious or impermeable layer is known, then we can refer to this figure. So basically the same x and y axis can get an idea about the required depth of penetration to prevent the hydraulic failure. And this is again a very useful tool in the planning stage. This figure, x-axis gives the stiffness of the excavation support system. The EW is the modulus of elasticity of the wall material, whatever the wall material. IW is the second moment of area per unit out of plane length of the wall. H is the spacing of the supports, vertical distance between support levels. It's the average spacing between support levels in the excavation support system. So we can calculate this value, and the gamma H over Cu is the undrained shear strength of soil of clay. This figure is developed for clay type soils. We can get an idea about the likely deformation of the wall. Movements generally less than 25 or between 25 to 75 and so on, can get an idea. So it's a very useful tool during the planning stage of the excavation. We can select the stiffness of the wall, the spacing, all these can be adjusted for more detailed analysis during the planning stage by referring to this figure. And this is proposed by Peck. So depending on the normalized settlement, this settlement over the depth of excavation, and this is the distance from the excavation. So he proposed 3 zones, 1, 2 and 3, zone 1, zone 2 and zone 3. If the soil in the excavation is sand or hard, soft to hard clay, mainly stiff soil with average workmanship, so he proposed that the settlement profile with the distance from the excavation would be something given by this line. So for very soft to soft soils, it is given by this. So the settlement and the settlement and the distance from the excavation, the variation would fall into zone 3 in such case, very soft to soft clay. So a lot of studies have been carried out to check the validity of this the diagram, and it has been modified several times. This is based on, this is a modification done based on field monitoring data in Chicago, around Chicago area. So they propose these 3 zones to be like this after carrying out some analysis. Zone 1, 2 and 3. The PEX regions have been modified. This is another useful figure. So it says this again for clay excavation in mainly clay type soils. Maximum ground settlement is y-axis is the maximum ground settlement, x-axis is the lateral deformation, maximum wall movement. So in the worst case scenario, maximum ground settlement is equal to the maximum wall movement for most of the case, if the excavation is mainly carried out in clay type soils. So this figure gives a method for calculating the settlement away from the excavation. So it is approximated by the settlement profile. The ground settlement profile is approximated by a parabola like given in the equation. So this equation can be used to estimate the settlement away from the excavation. So I am not going to go into the details. Some factors are being proposed for the workmanship and the construction difficulty. Mainly they are, for average type workmanship and average type construction difficulty, you can take these factors as one. So it's mainly it's like a parabolic variation of settlement. With that, I would like to discuss a little bit about the finite element analysis, because nowadays finite element analysis has been widely used in the design of deep excavations. So ideally speaking, deep excavations are 3-dimensional in nature, but 3-dimensional analysis is quite time consuming, and for normal design work it's not feasible. Therefore 2-dimensional idealization is widely used. 2D analysis is widely carried out for the analysis and the design of deep excavation, geotechnical analysis. So in the 2D, I'm talking about the 2D analysis, finite element analysis. So some general steps involved in the analysis are listed here. First, we have to idealize the problem into 2D. You have to select the dimensions, the soil. We have to identify the soil layers, external loads, what are the structures on the retained side, and so on. And then we have to select appropriate models and input parameters. This is the most difficult part, selecting the input parameters. So if you input rubbish, you will get rubbish as the results. So this is the most difficult part in the finite element analysis, that is giving the appropriate input parameters. So then we have to induce the correct boundary conditions, create the mesh, then calculate the initial stresses before doing any construction. What are the initial stresses of the existing ground? Then we have to simulate the construction sequence, and the results has to be interpreted in the right geotechnical and structural context. So two methods are available for the idealization of 3D problems into 2D, plane strain idealization and axisymmetry idealization, as shown here. The plane strain idealization is used if the vertical cross sections taken parallel to the problem are quite identical. Axisymmetry idealization is used if the problem is symmetric about an axis. like circular excavation. You can use axis symmetry idealization. Rectangular type excavations, a plane strain idealization can be used. One example is shown here. This is an actual project. This is already completed now. The structure is already being constructed. So this has been idealized using the plane strain idealization, and you can see the different sections for the analysis. We are going to this entire problem. This is a three-dimensional problem. So you can see here with multiple levels of excavation.
කවුද ඉන්නේ මේක අයි කරගන්න අර ගැරෙන්නේ කරන්නේ
Wait. So multiple levels of excavation. So we have to select different sections, plane strain, but we have to select different sections for the analysis considering excavation depth, the support conditions, soil conditions, and groundwater conditions, right? So by considering the subsurface conditions, the external loads, the depth of excavation, and the groundwater conditions, we have selected these sections for the analysis. So and this is a very wide excavation. Therefore, the entire section, let's say for example section AA, cannot be analyzed at once because it's quite wide compared to the depth. So therefore this section is divided into left hand side and right hand side. So two sections were analyzed separately. So plane strain, but different sections were analyzed. The external loads, as a general recommendation, if you have structures on the retained side, right, on the retained side, a general recommendation is to use a surcharge of about 10 to 20 depending on the importance of the structure. You can think of using a value between 10 to 20 per flow as the surcharge on the retained side. The point loads, if there are point loads, you have to convert them into a line load for two-dimensional analysis. And so the types of walls, in the 2D finite element analysis, you have to idealize, different types of wall using a plate type element. The idealization of different types of retaining walls into plate elements are explained here, so I am not going to go into the other details. So for secant piles, the cross-sectional area of the plate and the second moment of area of the plate can be calculated by given these equations. So I will not go into the details of this. Then different lateral support systems, anchor supported walls or props supported, strut supported walls. We can model these anchors or props using the different different elements available in the finite element software. So for prop supports, strut supports, the node to node anchor elements are available in most of the finite element software. So you connect one node to another node, or if this end is fixed, this end can be assumed as relatively fixed, and if it doesn't move, we can even think of using a fixed end support as the anchor support. And this is about the effective length of the fixed end anchor. The distance from the wall to the king post can be used as the effective length of the fixed end anchor, and this is about the horizontal spacing of anchors. So we have to input these details in the finite element because we are carrying out a two-dimensional analysis. The model, the boundaries. So we have to select the boundaries sufficiently away from the excavation area, excavation region. So it is generally recommended to maintain a gap of about 1.5 to 2 times whatever the height of the retaining wall, the embedded retaining wall to the boundary, to avoid any boundary effects. So similar for the other side as well. So this is again another example. These are taken from this the Capital Twin Peaks project, the different sections taken for the analysis, and you can see how the boundaries are selected. If the excavation is symmetrical excavation, so symmetrical means the loading, groundwater conditions, subsurface conditions, everything has to be symmetrical. In such case, the line of symmetry can be used as a boundary, because through the line of symmetry no lateral deformation takes place, right? Everything is symmetrical, so no lateral deformation, vertical movement can take place through the line of symmetry, therefore we can use it as a boundary. And about the selection of the material, I told you that this is the most challenging part. One major input to the finite element programs is the E value of soil, the elastic modulus of soil. And here you can see the different definitions for the soil E values, because the soil stress strain behavior is highly nonlinear. So which value should we use? E naught is the initial stiffness, that is also known as the small strain stiffness. For dynamic analysis, we can think of using E naught if the strains are quite small. For most of the general applications, E50 is used for the analysis of the soil behavior. E50 means the 50% of the peak stress, that is this point, is joined with the origin, and the gradient of that line is taken as E50. So soil behavior, although it is highly nonlinear, is approximated by this E50. So that value is widely used as the elastic modulus of soil for settlement analysis and so on. And this one is called E unload reload value, because when soil is unloaded, it is over consolidated, and it shows a stiffer behavior. So this E unload reload value is shown there. And for finite element analysis, because most of the areas in an excavation will be subjected to unloading during a deep excavation, it is recommended to use E unload reload value. So the same is explained in detail here. You can see that this is a typical deep excavation problem. You can see the passive side is unloaded because of the removal of the overburden, and active side is also unloaded because of the lateral movement of the wall. So soil will be mainly subjected to unload. Therefore, it is recommended to use this E unload reload value. Generally speaking, E unload reload value is 2 to 5 times larger than the E50. Right? So as a recommendation, I can suggest to use at least 2 times E50 or 3 times E50 as the E value of the excavation problems. Then about the interfaces, because we have a structural element, that is the embedded retaining wall, and you have soil. So interface, we have to introduce interface elements and reduce the shear strength along the interface. The interface strength reduction Coefficients are shown here, and these are quite typical values. And regarding the modeling of the groundwater condition, so if the entire subsurface is permeable, seepage can take place underneath the retaining wall, assuming that the wall is impermeable. So wall is impermeable, seepage takes place underneath the wall. So in such case, we have to carry out the groundwater flow analysis. Like as shown here. If the wall is permeable, like in the case of solder pile retaining walls, or retaining walls with like concrete plugging, in such case the wall may be permeable, so so this kind of seepage can take place. So if the wall is designed as a cut-off system, where the wall penetrates into an impermeable layer and the wall itself is impermeable, then on both sides, active and passive sides, static water levels prevail. So static water pressure can develop in such case. So by considering the appropriate the pore water condition, we have to model it appropriately in the finite element analysis. So I think I have so come to the end of the first part about the introduction and the analysis and general guidelines on analysis and design. So once we have the finite element results, we have to interpret them in the right context. Lateral deformation, anticipated settlement, the structural the forces, bending moments and shear forces along the wall can be obtained. Maximum axial forces on lateral supports can be obtained through finite element analysis. Then the earth pressure distribution, mobilized earth pressure distribution and pore water pressure distribution can be obtained through finite element analysis. We can make use of this for conventional factor of safety calculation as well. And one very important aspect is monitoring. Monitoring records must be used for validation of the finite element analysis and for the calibration. So for the validation and calibration purpose, monitoring records are very useful. So I am going to talk about this in more detail in the next session. So I think I have come to the end of today's. So from next week I would like to discuss about different groundwater control systems, how to select the different systems, and what should we do if the things are not going as expected, contingency plans, remedial measures, and those details will be discussed in the next class. So thank you very much for attending.
Thank you, Dr. Nalin, for your very informative presentation. Now we will have the question time. The audience can raise the question and they can use the chat box. Actually, I am operating here without power and I have certain difficulties, but I will go through first the chat box. Let me see that what are the questions raised here. Question is, in case if it is required to carry out a deep excavation in peaty soil, then how to select earthwork support system? The question is from D.H. Jayawardena.
Yes. So actually the selection of the excavation support system, it depends on the depth of the excavation, the condition of soil. I think if it is peaty soil, I expect that the groundwater table is very close to the surface. So what is, do you have any idea about the excavation depth?
Jayawardena?
Yeah. somewhere around 10 meters.
So in that case, I would recommend a diaphragm wall.
Okay.
Yeah.
Thank you.
May I add a little bit on that, Dr. Nalin?
Yes.
If we have very soft kind of peaty soil, it may be a very difficult thing to do the trench excavation, because to stabilize the soil during the installation of the diaphragm wall. What do you think about that? I feel something like sheet pile or something similar to that, or even the jet grouting may be not very effective. But what is your response on that stability during the installation of the shoring system?
Yes, I agree with you, Mr. Sabandu. The panel excavation can be difficult in peaty soils because particularly the stabilization of the panels, the excavation using bentonite would be quite difficult, I agree. But the sheet piles, the problem is 10-meter excavation. For 10-meter excavation, sheet piles I think is not feasible because of the stability problems, and you have to weld the sections and so on. How stiff is the how soft or stiff is the soil? Do you have any idea about the CU value? Undrained shear strength of the soil? Is it very soft?
Very soft. It will be very soft like that, doctor.
Okay, it's a very soft material. 10-meter deep excavation, right?
Yes, yes, doctor.
For what kind of application it is?
Actually, these are not a real scenario. Just
Okay.
we are these days doing some kind of work in Kerala for housing. Soil investigation has been done. Still, the
I
report
feel
was
that you may need some secondary, uh, excavation support system in such case.
in such case. Yeah.
Yeah, not just one.
And also, it all depend on the soil profile. Also, I mean, now if the peat is existing, that means the groundwater table also very shallow, and maybe whatever the shoring system, you have to extend it to the permeable layers or the bedrock. It is a very tricky situation. I think unless you study every aspect of that, it is very difficult to predict one particular system. I just propose this sheet piling because it can be sent without much disturbance to the neighborhood, because because of the soft soil. And also, it may be possible, I mean, with difficulty, some kind of secant pile also, but as Dr. Nalin indicated, it all depends on the softness of the soil actually. But diaphragm wall may not be possible because you expose a large excavated surface during the installation of shoring system. But piling, of course, you can reduce that risk. I know that. That's why I think something like sheet pile or secant pile may work. But if the peaty soil is has some kind of strength, even the grouting with some kind of shoulder system, even sheet pile system may work. But anyway, it is very difficult to predict without knowing all the factors and all the condition at the site.
Yeah, correct. I think.
Okay. So then the next response is Mr. Gates, this is not a question. He says, thank you very much for this type of session, knowledge sharing to the engineers and professionals. Special thanks to SLGS. You are welcome, Mr. Gates. Prabhat, everyone, could you please share the presentation? And I think Dr. Nalin has to decide on that.
I will do.
Then Mr. Our engineer Dilan, thank you for useful presentation by Dr. Nalin and SLGS. In practice, the bilinear Mohr-Coulomb model is commonly used, though it is generally not recommended for detailed finite element analysis. Are there any other soil models that we can use, and what information is required from the soil study for them? Number two, do we need to consider EQ loading,
Stiffness modification factor.
loading and no stiffness modification factors when modeling a retaining wall?
Regarding your first question, are there any other soil models? Yes, in other countries, they're widely using the hardening soil model, like parabolic soil models. It can model the nonlinear behavior more accurately, and it is suitable for stiff soils as well as soft soils. So the nonlinear soil models, but the problem is such models require a lot of parameters. So my idea is, in Sri Lanka we don't have advanced laboratory facilities to determine those parameters accurately. So rather than using a very accurate model with a lot of uncertain parameters, I think it's better to use a less accurate or conservative approximate model with more certain parameters. So that is my opinion. I'm talking from the Sri Lankan context. So in other countries, those are available, like the stiffness parameters, like the soil modulus E value varies with the stress level. So that is given by a parameter called M. So this M value, there are in literature some values are given. But are they really applicable to the residual type soils in Sri Lanka? Still we don't have any evidence on that. So therefore my suggestion, although there are advanced models, we are still we don't have advanced laboratory facilities to determine the required parameters for using them.
Dr. Nalin, may I also contribute something on that?
Yeah.
Actually, we are talking about very sophisticated analysis, but our data is very, very poor. Actually, we don't, I am talking about Sri Lankan context.
Yes.
We don't spend much resources to find out correct parameters. And also we have to keep in mind that soil is not a man-made material. It lot of things will vary within the site, and we can't go with 100% accuracy in our analytical procedure. And because of that, it is not like structure. If you talk about structures, we are talking about all man-made construction, and exactly, you can control exactly the material. But when it comes to the underground situation, it is all naturally made or God made. And in that situation, your analysis also should match with the accuracy of your data. And as very correctly Dr. Nalin indicated, we don't have certain facilities to find out very accurate soil parameters. And mostly people are very, very reluctant to spend much resources or money for that kind of investigations, and because of that, I mean, that is one side of that, and also even we go with very, very accurate kind of analytical tools, you may not get desired results because everything will depend on your input data. If your input data is not accurate, whatever, I mean, you may not get what is desired, I mean, what is expected. That is my comment, my small comment on that.
Yeah, I totally agree with you. Do we need to consider EQ means I guess you mean earthquake loading, right?
Yes.
Yeah.
Yeah, that's good. Thank you.
So most of the deep excavations in Sri Lanka, we don't consider earthquake loading because they are of temporary nature, and I mean, they are not in a very seismic region, so we don't consider the earthquake loading during deep excavations. None of what I know. Then the stiffness modification factors when modeling the retaining wall, that also we don't do. Yes.
Yeah, Dr. Narin, I think you are correct. I mean, we are considering very short period, and also Sri Lanka is not a very earthquake-prone country. I mean, it may be not very logical to consider earthquake loading for that kind of temporary structure. And also, I'm not very sure what you mean by stiffness modification. Can you explain, Milan, what you mean by the stiffness modification?
Sure. Yeah, generally, um, I mean, for any reason, if we are to expect a certain maybe cracking in the diaphragm wall due to maybe unpredictable lateral loads or any other effect, some reviewers generally ask for what is the stiffness modification that we are using, and generally they expect around 30%, but I have in reports that I have done, I have got away with using 15%, but it's always something that reviewers ask when they look at a retaining wall or a diaphragm wall design.
Yeah, what I mean, the using crack section may not be a very prudent thing actually. And also, I mean, you have to, I mean, that's why I'm telling you again, now what Dr. Nalin shows about this in conventional or traditional method, when you calculate the earth pressure, I mean, there are so many approximations you do and redistribution and all that depend on the stiffness also. I mean, that's why I'm telling that you have to use the stiffness, whatever the stiffness, not only the bending members, even the anchors and also the props, struts, all depend on the soil, again, soil pressure. I mean, the movement of the soil will vary the uh, earth pressure distribution. That is the main thing you have to consider in your analysis. What is your reaction, Dr. Nalin?
Yeah, in my opinion also, since we are using conservative soil properties and in the idealization of the subsurface conditions also, we do lot of approximations which are on the conservative side. So lateral earth pressure that we calculate are quite on the high side than what is actually expected in the site at the site. So therefore, I also agree with Engineer Sabandu. So we don't have to do that for the wall. It's a lot of conservative assumptions are there.
Yeah, let's go to the next question. K.S. Alshana. Peat's acidic sheet piles may get corroded. Yeah, I agree, but for the short term, now shoring is a short term business actually, and also sometimes you will take sheet pile out if there is a possibility. I don't think it is a big problem. And also, if you have the for the permanent purposes, you can apply some odd bituminous. Now, if you see Wellavata Canal, they have used sheet pile wall for the canal embankment protection, and that wall is there for last, I think, 15-20 years. We can't see much corrosion in that because of the corrosion protection they have done there. And also, I mean, if it is temporary thing, I don't think it will be a big issue. What is your opinion, Dr. Ali?
Yeah, one of my concerns is also this corrosion, but as Sabandu said, for temporary applications, it's not an issue. And this permanent sheet piles are working quite well, in for most of the applications I know.
Yeah, the next question from Engineer Nandana Abhay Surya. This question is there any guide to select embankment slope, cut slope without any support? I think this has been touched by Dr. Nalin at the very beginning. Can you elaborate a little bit on that?
Oh yeah. In the very beginning, I talked about open cut excavations. There I presented some general guidelines, but those guidelines are actually developed for excavations less than 6 meters. That I have to say. Excavations greater than 6 meters, there are no, standard guidelines. We have to do an analysis and decide on the appropriate the slope angles. And the other condition is, no surcharge is considered at the top of the crest.
You need and what I say is we have to be very careful.
Your voice is not very clear, loud.
Okay, I will go to the next question by Engineer Subrahmanya. What information would be useful? What are renewable ground anchors now available as proprietary? And removed in the progress of basement construction.
Hello.
Yeah, I don't know about this movable type of anchors are used in Sri Lanka, but in literature and also in case studies, I have seen application of those. But at the moment, I think the main problem in Sri Lanka that we don't have proper law. I mean, if you want to go to the next door man's property, he can simply object that. I mean, there is no way you can convince that person in legal framework unless he gives his consent. But in a country like Germany, they have some kind of guidelines, and also they appoint, two parties will appoint technical person, and they will discuss it and decide on those things. Now in UK, that is the normal practice actually. But in Sri Lanka, we don't have that kind of tradition, or we don't have that kind of practice available. And because of that, normally what happened, the land owner will object to install your anchors in his property. Then in that case, you may have to go with internal strutting. That will be not a very construction friendly method. But that is my experience. Anything else, Dr. Nal?
Uh, Hello, can you hear me?
Yeah, I can hear you.
Yeah. The helical anchors are available in Sri Lanka. That I know. So
They used in
it
Sri
has
Lanka
never been used.
for shoring. Have they used in Sri Lanka for shoring?
For shoring, no, not yet. They are using for at the moment they are using helical anchors to support tower foundations to enhance the uplift capacity of tower foundations. They are using for one CEB project, uh, and uh, and they say that it can be used as an alternative for soil nails and ground anchors, but it has not been used. But in other countries, they have used it.
Do they need special equipment to
No, actually, equipment are minimum. It can be attached to the excavator. The torque motor can be attached to the excavator.
right, okay. Yeah, we have some more questions. Mr. GSK Karyosam, if boulders are encountered during the deep excavation, how to deal with such situation?
Uh, Deep excavation means during excavation or during the installation of the wall.
I think you may be asking that one. No? That is a tricky part. Not the excavation, of course, you can deal with boulders. That is not a problem.
Yeah.
But during the installation of uh, storing system, it may be a problem.
Yes, it's a problem. Particularly during the installation of sheet piles, it's an issue.
Yeah, my experience, Dr. Naveen, and Karyosa, that in
Yes, sir.
Central Bank we had this kind of problem. We had boulders, and because we had a secant pile wall and boulders was a problem. But what we did was, if it is very shallow, we excavate it and remove it and refill it and with the board pile wall or secant pile wall. When it is very deep and also very big, we drill through those boulders, but it's a very difficult task. And you need four cutters, and also it's a very slow process. But we did that.
So what happened when in that case, seepage maybe take place through this interface where meeting the second pile to the rock? Do we have to do any chemical anchoring or something?
No, no, we didn't have that kind of big problem, but we did. But you can do some local treatment. You can do stock treating, or even you can do grouting in upstream side of the boat pile wall. But all depend on the situation, depend on the soil condition also. Now, if you have like this kind of soil, can be controlled very easily. But if it is that kind of soil, maybe you have to do some kind of grouting in between the piles. There are, I mean, those things are at least in Sri Lanka. It's not a very new thing, but finding boulders is a very difficult task even for any kind of cloning system. And seed piling maybe not even seed piling may not be possible. Only thing what we can do is we can, if it is very deep, we can dry up to that point, whatever soil system, and excavation, do some kind of local treatment to support the soil and as well as to avoid the seepage also out in that kind of thing. That is my opinion. Anything else, Dr. Nalin?
Yeah, let me to this. If I mean, if you are carrying out a deep excavation in a boulder terrain, it's better to avoid anchors to go for support.
Yeah, we go to the next one. Udara Satin, Satin, can we model the soil as soil strength? In string constant, in finite element software like ETAP, if we specifically want to design structural elements of retaining wall, soil or reinforced stone, if so, if so, how to design soil K value? Dr. Nalin.
Oh yes, that's possible. ETFs so SAP you can use for modeling, like you are modeling a file. So it can be used, and K value, the horizontal spring constants can be used. I
Yeah, yeah, actually,
Yes, yes, yes.
I mean, instead of using finite element models, you can use the strength coefficient also in analysis of this kind of wall system. Any comment, Doctor?
Yeah, yeah. Yes, you can agree.
Then Mr. Senaka, his question is, please share the presentation. This is very useful to know. Okay, then Mr. Samita Vijayavardhana, in case of Amita Vijayavardhana, in case of leakages, water mixed with soil particles or water leakages of deep excavation supporting system, permanent system in Stockholm, what are the best possible solution to prevent those leakages?
Yeah, I will be touching on this in the next presentation, but to answer your question, now the first thing you are supposed to do is to stop the leakage. Small, very small leakage can be, let's say, if it can be managed uh, without doing a lot of additional work, I mean, it can be attended, but the say in sandy soils, if sudden leakage takes place, that can be a nightmare. So the first thing to be done is to stop the spurting or the sudden water movement by using clothes, gunny bags, sand bags. So try to cover the area with some fabric, and straw and so on, and try to control the seepage, and then cover the area with sandbags to prevent the loss of soil particles. Then you have to grout from behind to stop this permanently. Once the seepage through the wall is controlled to sufficient extent, you can think of constructing a shotcrete skin wall from outside.
Okay, Dr. Nalin, I think one more question from Prabhat. Is it possible to replace STD? I don't know what is STD. Cut of, cut off wall of earth dam.
Soil cement bentonite, yeah.
And
Uh,
soil cement
I think SCB means soil cement bentonite cutout wall.
using jet grouting method. I think it's possible.
Oh
Dr.
yeah,
Nalin,
yeah, it's possible.
right. I think we have come to the end of the discussion. We don't have any more questions, and also it is now almost 8:30, and we had a very fruitful, I mean, very informative presentation, and also very well presented, well prepared slides. And I think I must be very thankful to Dr. Nalin for his effort to do a very good presentation for the development of the society. And also, I must be thankful to all the participants. I think we have nearly 100 participants at the beginning. And also, we must understand we have lots of power cuts, and even I am operating with so no electricity. Uh, and I am sure that because of that, a lot of people are not have lost their opportunity connecting with our presentation. However, thank you again for the participants, and also uh, especially Professor Udeni and Vatsala, and finally our resource person, Dr. Nalini Silla, for your presentation. And our next presentation will be on next month by Dr. Nalin. I think we will discuss further about deep excavation, and we can discuss it further in the next month our work order. Thank you very much, and good night for everybody.
Thank you very much for the participants, and thank you very much, Mr. Nabandu, for the very active discussion. Thank you.
Thank you, Nalin.
Yes, sir. Thank you very much.
Thank you, Dr. Nalin.